Let's go to the constraints. The constraints for your solution is that the nums.length, which is the length of the array, that means the number of elements in that array, is going to be between 1, including 1, up to, I believe this is 10,000, right? 10 raised to the power 4. This is the number of elements you can have inside your array. And what is this nums of I? So if you were to iterate over this nums array with an integer I, the nums of I would mean the elements inside that array. So the element inside that array, that element itself is an integer between negative 2 raised to the power 31 and positive 2 raised to the power 31 minus 1. And this minus 1 is a concept in integer data type where it, I think, avoids you from cycling. Well, I'll need to take a look at that before I tell you this again. But yeah, look it up, how the cycling between positive and negative numbers work in integer. Like once you hit the limit, it switches to the other sign. So for negative, you hit a certain limit, you switch to the positive. It automatically starts storing the positive numbers. So we'll need to take a look at that, in a bit. All right, so we can solve this in many ways, but the approach I want to take is 2 pointers, okay? In order for me to move the zeros all the way to the end, also keeping in mind that they're not requiring any return type, which means that I cannot initialize a new array and store these elements in an order where zeros are falling at the end and the other elements are falling in the front of that array. All they're saying is reorganize these elements within the same array, okay? So let me write down an example array. Let's say this is the array that we are trying to organize so that 0 falls in the front and the the zeros fall on the end and the non-zeros fall in the front. What would I need to do to swap these elements within this array and zeros fall at the end and the non-zeros fall in the front? Okay. One thing I can determine is that if I find a 0 at any index next to a non-zero element, I should be able to swap it. So what if I swap it like this? Okay.
So if we swap it like this,
Mhm.
the complexity would be big O of n square.
Correct. So even not thinking about complexity, just seeing like how can we actually make this happen? But
So
you're right, of n square will make it like multiple loops, right?
yeah, multiple loops. Basically, if we swap uh, it from, for example, 0 with the 1, then it's gonna we need two loops. For example, for the next iteration, there would be 1 0 0 3 12. And if I again replace compare with the next one or with the 3, if I replace it with the 3 3 and 0, it would be 0 1
So you're
3.
basically going through a lot of iterations and a lot of checks. So even if you do an I and J with a nested for loop, if you have a
Yes.
large data set, what you're going to do then? You'll end up with an omelet, right? We don't want to go there, right? So a better approach would be you can actually do it with a single for loop, but I'm going to do it with a while loop.
I think
I'm
there
going to
is
go.
one more way that we can do it. Maybe, we can
Mhm.
check all the non-zero numbers and create if we are allowed to have extra space, then we can append all non-zero numbers in a new array,
We can't. That was
then
the
check
first
the difference
condition.
of these.
It is the
Oh, so we cannot use
No,
mm,
extra space.
it's
the
not
one
about
of
extra space.
Then what we can do is, Yeah, what we can do is we can initialize a left pointer at a zero number, the first zero, and the right pointer at the first non-zero. And then we swap them, and then we move the right pointer +1 and left pointer to the next zero element. So right pointer onto the next non-zero, and left pointer onto the next zero element. And then we keep swapping it this way. Then we'll end up with zeros up in the front and non-zeros. Sorry, non-zeros at in the start of the array, and all of the zeros would be switched to the end.
Right. So let me finish the solution, implementing the solution now, since you guys already have an idea how two pointers work. Okay, but I'll give this implementation of first diagrammatically, so for those who are beginners, they have an opportunity to understand. And then we'll move to the maximum subarray because that's more interesting. This question
Okay.
I'm just doing.
I'm so sorry. I haven't. I doubt it because I think so. We can, if we place left pointer over first index, zero index, I mean, and the right pointer on one index one, last index, 12 on 12, right index. So if we find something on the left pointer, if we find something zero, we can replace it with the right pointer, and then we jump left pointer to the next iteration and the right pointer to the previous iteration, I mean 3. And in this way I think we can do it, but I doubt it, this solution, because maybe at the end 1 3 12 would not be in the same order.
Right. Because let's say if you're so basically what you're doing is you're swapping non-zero element with a zero element. So you will not swap these until you have arrived at an index where you have a zero, right? I'm talking about for the right pointer. So if you arrive at 3 and then your I minus, this is I minus 2. So I minus 3 would be your, this will be your I minus 3, sorry, J minus 3. So even if you swap these, what are you producing is 3, 0, okay, and 12. And your I still maintains here, okay? And
No, I'm
now,
not saying this. I'm
mhm,
saying this, if for the first iteration, which is left, I am saying left, you are saying I. If let's say my left is non-zero, is zero basically, sorry, my left is zero, I am going to, and my right is non-zero, I am going to replace them.
no, this can't work because the order in the middle will get messed up. My assumption is that I haven't tried it. Um,
Yes, I'm saying so. The order will be disturbed of the non-zero elements,
hmm, right,
but the zeroth element would be at the last. So I'm not sure that either we are, while maintaining the relative order of the non-zero element. Okay, this is the constraint as well. We have to maintain the relative order of non-zero elements. Okay.
right, okay. So I think we should move on. Now the way we can solve this uh, is I'm going to take the same example, 3, 4. Okay, so the first thing I'm going to check is I can place my I here, okay? And I can place my J here as well. I think we need to find a better software I can annotate these things. This Zoom is very clumsy. We can do that later. 0, 1, 0, 3, 4. What if I start with I is equal to 0 and j is equal to 0? Okay. My idea is that I want to push these zeros to the right side. But before I push them, I want to cluster all the zeros at some point. And if I can organize the zeros, if I can cluster the zeros where I have a pattern like this, then the job becomes very easy. And all I need to do is keep pushing these zeros and this 3 will automatically follow the order of the array, and 4 will follow the order of the array. And now you're not just doing individual swaps, you are collecting the zeros, and then you are swapping them with the non-zero elements, thus maintaining the orders. So you're organizing them in an intelligent way, and I'll show you how this is going to take place. 0, 1, 0, 3, 4. I, J. Okay. Now, when I have I is equal to, when I have I and J at the same index, I should move my J forward. Okay. And now I should check whether J is a non-zero element and I is 0. Okay. If I is a 0 element and J is non-zero, I just swap them. Okay. And then I move my J to the next element, which is this one. And then I move my I to the next element. Now they have fallen together. Okay, I continue this. But meanwhile, if you can see here, J right now, it's equal to 0. It's a zero element, right? And I is not equal to J, so I should move my J to seek out a non-zero element. Okay, now my J has moved forward. Okay, I don't need to move my I right now. My I only moves once I have swapped, because now I wants to seek the next element, right? Now I wants to go the next closest 0. In this case, if I swap, what do I get? 1, 3, 0, 0, 4. Okay. And then since I've swapped this time, my I should move forward and I should fall here now. And then J should move forward. Okay. So now this I that swapped with 3, it moved to the second last element. Okay. And the J, it will move one iteration here. Now I cannot exceed outside of the length of the array. Is that right? Otherwise it will give me out of bound exception. Plus, I think I kind of messed up my iterations here.
Sir, you move I one index. No.
Hold on.
I should be at
Sure.
index 2.
It should be right here. And
Yes.
then when these swap, right? Thank you. Now J has reached the end. Okay. And when I swap J with I, 1, 3, 4. Okay. And this 0 goes here. This 0 stays in place. This 0 falls here. And now I have the I'm maintaining the order for a different day. This is not the array, right? I'm using a different example, 0, 1, 0, 3, 4. That's not the same as this one. If I apply the same rule here, I'll end up with this array right here. Does this solution make sense?
Yes.
Okay. Maha, did you get it?
Yes, exactly.
Okay.
Actually, I was pointing left and right pointer to the start and the end. If we place them in the start, we can get our answer.
Okay, how about you think about problems not in terms of patterns, but okay, what has helped me personally is that I don't just think about patterns. I read the data first. I make sense of the data first. And once I have understood what the data means, what it's doing, then I only think about which patterns they match, right? So if you're just directly thinking about left and right pointer because you've seen that example somewhere before, that may not be a good way to approach problem, right? Doesn't matter if it's easy problem or hard. You should always take the example and create your own examples, right? And then read and try to understand what the data is doing. Anyway, that was just like a random thought that came to my thought. This might help. But yeah, anyways, let's go ahead and I'll start implementing the solution. First of all, I'll determine the length of this array, right? I think I should just initiate this to left and right for just making it easy to read, right, is equal to 0. I'm initializing them to 0, so they start with the 0th index, okay? Second, integer. Okay, so for swapping, I'm using a temporary variable. This is a pretty common example, the way books do. So now I'll run my while loop. I want to run my while loop until j hits the end of the array. Okay. So in that case, I will do my left pointer as long as my left pointer is less than the length of array. This is the length, okay, denoted with n. So I'm putting my n here. And while I'm making sure my left makes it to the end of the array, I'm looking at few conditions. The first and most important condition is that my number at the left pointer is not equal to 0. Is not equal to 0, okay? If my number on the left is not equal to 0, what I want to do is I want to check for one more thing. If I and j are not equal to each other. If I and j are not at the same index, which I don't have an I and j, so I would say if left pointer and right pointer are not same, which means they're not following the same index. Sorry. In that case, I will swap. Okay. What I'm doing here is if my left number is not equal to 0, am I doing it correctly? I'm moving my right pointer if that is not equal to 0. Okay. Please catch me making mistakes.
So if shouldn't we have a while statement here? Because let's say if there are multiple zeros, then you'd keep moving the left pointer until it reaches a non-zero number.
I think we should be, that's a right for me. We are moving the right pointer actually.
But let's say if left is at any zero non-zero number, and you have to move the left at
right. In that
until
case,
you
we'll
find the
move the
first
left pointer. Correct. Yes, we'll move the. So in that case, we will move the right pointer. So you're saying what if at the first index you have a non-zero number? In that case, you don't need to move it because we want to have all the non-zero elements at the beginning of the array. The only time we ever make it a matter of discussion is when you encounter a 0 in the beginning or in the middle. If you already have a non-zero element on the left, then uh, you don't need to necessarily move left at once. But once you've explored all the rights, and then you think maybe there's something like, then you can explore left. But right will do the job for you for seeking out if there are any zeros. I hope that makes sense. Okay. Now we'll just, first what we'll do is we'll take the number at the left pointer, okay? And take the number at the left pointer and explain to you how this works. Just bear with me for a second. Okay, if this was I and J, what basically you're doing is
I think we are missing the left index. When left index is 0, the case when the left index is 0.
in the case when the left index is 0.
And the element at the left index is 0.
If the element at the left is 0,
Yes.
okay? In that case, I have I and I have J. This is right, this is left. What needs to happen here?
Yes, we are not checking it in this if statement.
So we're checking if, but we're checking if this J is not equal to 0,
Yes.
right? So this is not 0, so that will swap and 0 falls here.
But if there will be 2 instead of 1, they will also swap.
You're saying if it's like this,
Not 2 1.
2, 1.
Yes.
In that case, you need to keep looking for zeros. If it's
Yes.
not equal to 0, then you need to keep looking for zeros.
Yes.
Um,
Left is not equal to right, then they will be swapped.
okay, you're saying in case of 2, 1, and 0, if I'm starting with I and J here, okay,
Yes.
if my J is not equal, I move, first of all, they can't be at the same place, so I'll move J first, okay?
Okay.
I'll move J first. And now, is J a non-zero number?
Yes, this is non-zero,
Okay,
and
but at the
left is
same
not equal.
time,
Left is not equal to right. They will be swapped to 1. 0.
that's right. But what do we do when the J is actually equal to 0 and they're not at the same spot? So we are seeking out 0, but what if J is non-zero and the I is non-zero? In that case, we should not swap.
Yes. I think we initially set j equal to 1 when we define the right element.
Well, then what if we
In
have something like 2, 1, 1, 0? That still doesn't serve your purpose, even if you start uh, J
j,
here. And even if you start I here, you still have a J here that will swap these two ones.
no, we can manage it.
Yeah, in this case, it should fail actually. Why didn't I think
Uh,
of this?
I think we should assign right to 1 initially.
Okay, let's do one thing. Let me finish this real quick, and then we can put this custom test. And maybe you're missing out on something. My left starts with 0, my right starts with 0. My right moves uh, towards, if my right is not equal to 0, we'll just, for the sake of this, make this again back to if it's simple, if I is not equal to j, j.
Is this will be j inside while loop, j less than n.
Yes, that's
Yes.
correct. Yeah. We move I whenever, whenever.
And
Um,
j I if
this is
j,
this wrong.
yes.
This is J. So if j is not 0, initially,
So there would be one
no,
more
hold on.
condition,
If j is not equal to 0,
and
if nums, no, hold on. I can put an
nums.
n. Right.
I think there will be ends inside it, and nums of I equal to 0. Then there will be swap.
Hold on. Let me implement this real quick. And then my j should move as well, regardless whether I execute or not. So you're saying that you have you have a situation like this, or let's say a situation like this. Okay, your I is here, and your j is here. Is j not equal to 0? Yes, j is not equal to 0. Therefore, this condition is true. Is I not equal to j? Yes, I is equal to j. In that case, I should move. Okay, I should move, and then j should move. Let's take the old example, 2, 1, 0. We check condition while j is less than n. That part is understood. If nums of j is not equal to 0, is nums of j, right now I and j are the same index because they've initialized to 0. Is j is equal to 0? No. Yeah, true. This is not equal to 0, right? So in that case, what we do, we check, are I and j at the same spot? Yes, they are the same spot. Then do what? This condition becomes false, okay? And then we move our I pointer, okay? And we also move our j pointer. I think there's one more condition that you just mentioned, but what if, I think we're missing out on one more example for 2, 1, 0. We have checked if I and j are the same. What if I and j are not at the same spot, right? And j is not equal to 0 and I is not equal to 0. So first we always check if j is not equal to 0. Are I and j on the same place? No, they're not in the same place. In that case, you swap I with j. Yeah, it should fail in this case. Why is it not failing? I is not equal to j. Yes, they're not equal to j, and j is also not equal to 0. So you're saying I should put one more condition here? What's
Yes.
that?
And nums of I equal to 0.
Okay. So you only swap if your I is 0.
Yes.
Okay. Yeah, I think we can do that. Let's see. Let's run test cases and
Yeah, great.
it failed. So for this, if we do it like this, 101, we're getting the output 101 because we're only seeing if my j is not equal to 0, my j is not equal to 0, right? And my I is equal to 0. So in that case, I need to swap.
One index more.
We have to look at it from the beginning, actually. If my I is here, my j is here, okay? This condition stands true, okay? Therefore, j is not equal to 0, first of all. So I move my, j is not equal to 0, I move my j here. And then I check if I is not equal to j, I is not equal to j, correct. That's where you swap 0 and 1. But this will not function because nums of I has to be 0. but nums of I is not 0 here. Okay, so that's why this particular case failed and many other similar cases failed. Okay, and for your example, 2, 1, 0. Let's say if I exclude this part, all I'm checking is, first of all, my ing are here, okay, and I come to this condition. J is already less than n. Okay, that part is true. Is j not equal to 0? Correct. J is not equal to 0. In that case, we'll come to this condition. Is I not equal to j? I is equal to j. In that case, this becomes false. And that is why I move I once, and then I move j once. Okay.
J would be at index 1, I think.
J would be where?
Yes, you move J to index 1.
Okay. So now my I and j are at the same
Yes.
location. Yes, you're right.
So I think in line 24, it will be outside of if statement.
Yes, it is outside of the if statement, which means, again, this is false. They're at the same spot, right? They're the same spot, so this will again get skipped. It will again, these two will again get moved, and now they're at 0.
No, I will.
After replacing, why are you not moving a left and right pointer? You have replaced the values. Now you need to move your left and right pointer as well.
No, we haven't replaced anything. It's 210 for this case particularly, right? And we are not considering his. I'm trying to see why this code would work for 210. It will, but why you're saying why 2 will not swap with 1 is because as long as they're in the same spot, all that will happen is I will move forward and J will keep moving forward.
Sir, I think we
Mhm.
have to move I plus plus in line 24 to outside of the if statement.
Why?
Because I only increment when the condition is true. This one condition, yes. I
Okay, so
only
you're saying J should not move.
no
Sorry,
no
I should.
I should move every time if there is if condition is true or false. On
Hold on. You will only move J if it is not equal to 0, which means, for example, if it's 1, right? If it's 0, then you have explored the J. You're moving J anyways, right? But for now, if your I and J are at 0, right? And then you have, let's say, I has already explored this, right? And you have 1 here, or you have 0 and 1 here, okay?
sir,
In
can
that
you
case, your I will move forward, and then your J will move forward.
sir, can you explain the case that we are missing 101?
101, the problem is that your statement is saying if your J is not equal to 0,
Yes.
okay? In this case, your J is not equal to 0, but
Yes.
I is equal to J, so we skip this altogether, and then we move our I. Okay, we move our I to what? This placeholder right here.
No, our eye is not moving here.
Where is it going?
Because the our control will not come inside this if statement.
Yeah, that's what I'm saying. Your I is outside of this if condition. Okay.
No, this condition nums of j equal to 0.
No, is nums of j equal to 0 right now? It's not. It's 1.
No.
Okay.
Yes.
That's why we're able to come to this if condition. But this if condition became false because I. Okay.
This statement would be false in first case. I think we should
Yes.
move I plus plus in line 25.
It doesn't really matter if you put it here or here.
I said this matter. I think this matters.
Then you're just incrementing I plus plus and j plus plus every time your loop runs. So you are skipping two positions forward. What you want to do is you want to check two things. First of all, your nums of j is not equal to 0. Okay? Your nums of j is 1 in this case. Second, I want to check if I is not equal to j. But here I is equal to j. So this became
Yes.
false. And then I don't want to keep my I here. I want to move my I. Okay? And then also I want to move my j because this is my right pointer, right? I can't keep it here. So I move my
Yes.
j. But now in the second iteration, is nums of j not equal to 0? It is equal to 0, right? But in this condition, your nums of I, if
So we
nums of j is
so
not, this is false. Okay, hold on. This is false and this is true. And you have an and condition between this. True
so
and
we
false. This will not
so
get executed.
okay. So we can place the second condition inside if statement at line 17. I think this would work.
Hold on. What are you saying?
In second statement at line 14, the second condition, nums of I equal to 0, we should move here.
Where? Line number?
Yes.
Line
Line
number?
number 17.
Inside
Inside if statement.
here.
Line number 17. No.
Mhm.
Inside if statement.
This if
Yes.
statement or this if statement?
This second. The condition would be I not equal to j and nums of I equal to 0.
Okay.
No,
Let's
no,
try.
sir. Inside if statement with and.
Inside the conditional? Okay.
Yes, yes,
You want to put and nums of
yes,
I is equal to 0.
yes.
Okay. So
Okay,
now what
why
you're
are you
saying,
comparing the indexes?
so basically what you're saying, I think we're going to Zohaib, what you're saying is in 101, when I was here and j was here, for example, and the nums of I was equal to 0, okay,
Yes,
which is, it is not equal to 0 in this case, right? So nums of I is, hold on, I is not equal to j and nums of I is equal to 0. It is not equal to 0. That's why this will never get swapped.
yes,
And then you'll move I forward and you'll move j forward.
yes,
I think this could work as well.
yes.
Yeah. Let's try this. Wonderful. Amazing. Yeah. So I guess we have explored this enough. Don't have much time left. Does anyone else want to present some question? Anyways, your solution works, and I believe my solution will also work. I wouldn't have presented if this didn't work before. So let me try this. This one works as well. And now you need to figure out why this works. I'll leave it to you. I've spent enough time on this question. I'm tired. But yeah, if someone else has any question, wants to present or anything, please go ahead. Otherwise, at least I can explain the maximum subarray and then you guys can attempt on your own. I'll give you the solution if you need. Does anyone else want to present? No? Okay, I'll take that as a no. We won't be able to completely get into maximum subarray because I try to make sure we are We're not just jumping, we're understanding each and every step. Because without that, how would we learn? Okay. So maximum subarray. If you have not come across this problem before, not attempted before, this is a good opportunity. What I'm going to use is the same two-pointer approach, but it's going to be a bit different. Anyways, what they're saying is, given an integer array nums, find the subarray with the largest sum and return its sum. This is your nums array, okay? And you need to find the subarray that can give you the largest sum, and then you need to return that sum. Okay, sounds familiar? We did something similar to this in the, I think in the product X itself. But here the ask is very specific. In this array, for example, you need to find that subarray that will give you the maximum sum. It can be this entire array, this can be a small array, it can be a single. I guess you have to have at least two elements here, right? And so on and so forth. But let me show you a brute force approach that I did. Okay, how about I just ask you guys, what do you guys think about this? How should this be solved? Can anyone give any suggestion?
Should we sort the array?
We cannot sort the
Talking
array.
about the brute force or the optimized solution?
It's fine, you can give the brute force.
I think we can use nested loops or obviously the brute force and find all possible subarrays and keep track of a maximum sum and return it. But that would fail if we submit this, it could exceed the time limit.
It will actually. We'll use nested loops, and the idea is that I want to explore all the possible subarrays and then add all the elements in those possible subarrays and keep comparing the last maximum with the current computed maximum. And keep updating when your current maximum becomes greater than the last maximum, right? Who gave this idea? Who's talking?
Yeah.
Okay, Hadi, right? Yeah.
Yes. Yes.
This is the idea, right?
Yeah. Yeah.
Due to shortage of time, I'm going to just take the for loop from my code, and for the one that it actually failed, 200 test cases passed and 10 failed. So this is the worst. This is even worse than O of n square, using 3 nested loops, or you can say 2 nested loops under one, but it's like 3 loops that run underneath each other. And how we use that is we start with a small window and run it for each element. Okay. And then we increase the size of our window. And then we do for 2 and 3 and 4 until we arrive at the complete length of the array. Okay. Now there are some important concepts here. If this is the length of your entire array, okay, and I call it n, what will be the size of your window? How will you compute that?
The
From
difference
this
between
n, you subtract the window size, right?
yes,
Yeah, correct. Thank you.
The
And
difference between right and left plus 1.
yes.
that works too. And this is just the size of my window, okay? And minus the window size. Sorry, this will give me the, I got lost, sorry. Okay, first we initialize our window size to 1, okay? So when our window size is 1, we put a start pointer and run the start pointer to n minus window size. Okay, which means that this window right here can only, it has a starting point and it has an ending point. So this will compute the window size, and this pointer, the start and the end one, it can only go until here. Okay, so if my window is here, and this is the length of my entire array, for me to this is the length of my entire array. My window has arrived here. Okay, if I do n minus window size, this gives me how far can the start point go. My window starts here, start point. Okay, and it has a start and ending point. If I do n minus window, basically we're subtracting from the total length of this array the size of the window, and this will tell me how far can my window go. And basically what we're computing here is length of array minus 1. Did you guys get this? Okay. The third loop that will run is once you have a window and you have elements, you want to run a loop inside this array and add all of these elements one by one. And how this window slides is if you have these elements, your initial window is of size 2. If you move this window, 3 gets included and 1 gets excluded. And now you have 2 and 3. Same process repeats. 4 gets included and 2 gets excluded. And now you have 3 and 4. Okay. So you're taking the window size, okay? You're taking the start point and the window size. You're telling it your start point is this, and this is your entire window size that you've computed. And you want to run your internal for loop and from start point to the length to the end of the window. That's how this for loop is working. If you're playing golf, okay, and there's a hole, and someone tells you if you shoot from the point where you're standing, if you shoot 3 meters exactly, if you measure 3 meters, your ball will end up here in that hole, right? That's how the same pattern we're applying here. Your starting point, 3 meters, and you just hit your shot and it ends up here in the hole. So your sliding, the iteration within your sliding window ends up here in the hole. You're standing here. You shoot your shot, your iterator will go over all these elements and keep adding them here. And once one window is computed, it comes back to this loop and resets this sum equal to 0. Okay. And once this entire thing is done, then the size of your window increases, which means that you have slided your window. When this loop ends, you've slided your window all the way to the end of the array. Okay. All right. Let me jump back to what would be an optimal approach. An optimal approach would be, instead of computing all the, I'll give you the intuition now, only 4 minutes left. I can't go into diagrammatic explanations. Instead of computing all these subarrays, what if I assume that, first of all, I don't have a strictly increasing ascending array. If this was the case, I could have just added all the elements with just a single for loop, and I would say this is my maximum sum. Neither do I have a strictly decreasing, which again is the same thing, nor do I have, these two are the same thing, nor do I have all negatives. In all negatives, I think if you can find the largest element, largest negative number, that will be your win, right? You don't even need to add these. But where you have positives and negatives, there the approach you can take is assume that while you're sliding, while you're moving your pointers, while you're increasing the size of your window, you are getting a bigger and a bigger number, unless you hit a number that resets that your current sum. For example, if I'm doing 1, 2, 3, and then there comes a negative 100, right? Since this is an array, and unless I go through these, I cannot get to the good part on the other side of 100. So this is where I reset my window, because negative 100 is resetting this number, right? So I move to the next positive window and I keep moving. So as long as my window is increasing and